So we're going to use the lessons I taught you in the converting video, and we're going to apply it to these questions. So we have number one, we have a 2050, and we want to convert it to all the different notations. So for decimal notation, remember we just do the numerator divided by denominator, and that equals 0.6, I think. 20 divided by 50, sorry, 0.4. Okay. For metric notation, remember we're setting up a proportion, and metric is 6 meters over x. So equals 6 over x. We cross multiply, so we get 300 equals 20x. We solve for x, and we get 15. And so our metric notation is 6 over 15. Okay, for m notation, it's the same thing. We set up a proportion, so 20 over 50 equals 0.4 over x. Cross multiply, we get 20x equals 20, and so x equals 1. So our m notation is 0.4 over 1m. And then for point notation, remember you go from Snellen to m notation, and then to go from m to point, you take the denominator of your point notation and you just multiply by 8. So we'll do 1 times 8 equals 8, and that's our point. Okay, and then we just have two more. So we have the MAR, which is you do the numerator divided by denominator. Sorry, denominator divided by the numerator. So 50 divided by 20 is 2.5. And then for the LogMAR, we take whatever we got as our MAR, we just take the log of it. So log of 2.5 equals, I'm just going to calculate that, 0.397. Okay, so for number two, I just want to remind you that visual acuity, if anyone asks you the definition, is testing distance divided by letter size, okay? So we have our testing distance, which is 33 centimeters over letter size, which is 0.5. Okay, and then, and remember, so 33 centimeters is the same thing as 0.33 meters. I think you'll get the same answer even if you keep it as 33 centimeters. But if we put it as 0.33 meters, it'll make more sense when we write our final answer. So 0.33 over 0.5 equals, and by that I mean like leaving it as meters as opposed to centimeters, equals 0.4, because 40 centimeters is 0.4 meters over x. We cross multiply, so 0.33x equals 0.4 times 0.5 equals 0.2. And so if we divide that by 0.33, we get x equals 0.6. And so our answer is 0.4 over 0.6. And then I just want to confirm that's right. Yeah, and 0.4 over 0.6 m. Okay. So number three, your patient reads 2060 plus 2 on the LogMAR. Sorry, yeah, on the 0.1 LogMAR progression acuity. What is their acuity in LogMAR? Okay, so step one for this is to ignore the plus 2 and just figure out the LogMAR. So if we do, to go from the 2020 to the MAR, we do 60 divided by 20 equals 3. And then we take the log of 3 equals, it equals 0.477. So we'll just round to 0.48. Okay, now for these problems, when you have like 2060 plus 1, 2060 plus 2, for whatever number you have plus, you're going to subtract 0.02. So for plus, you subtract 0.02, and for minus, you add 0.02. So we have our LogMAR is 0.48, and it's 2060 plus 2. So we're going to subtract 0.02 twice because it's plus 2. If it was plus 1, we'd just subtract 0.02 once. But since it's 2060 plus 2, we're going to subtract it twice. So minus 0.02 minus 0.02 equals 0.44. Then, so I'm going to check my answer. Yeah, that's correct. Okay, and so if we do the same thing for the next problem, we have 2040 minus 1. So again, we're going to find the MAR, which is 40 divided by 20 equals 2. And we're going to find, that's the MAR, so we're going to find log of 2 equals, log of 2 equals 0.3. And then remember, so when there's plus, we are subtracting 0.02. When it's minus, we're adding 0.02. So we're going to take 0.3 plus 0.02, and we're going to get 0.32. And I'm going to check my answer one more time. Okay, that's right. Okay, and then we have number 6. These problems sound scary, but they're not. So how far from a 5-foot tall road sign does a patient with 20/60 acuity have to be to see it clearly? So these problems all boil down to the same thing. She'll give you 2 out of 3 variables and you solve for the third. So we have the size of the letter, we have the distance from the letter, and then we have the angle, which is the same thing as the acuity. So we know that the size of the letter is 5 feet, or the size of whatever we're looking at, and we know the angle because the patient is 20/60. Okay, the important thing for this is that first you have to find the MAR. So 60 divided by 20 equals 3. So we know that the MAR is 3. We can use that to figure out this angle, but that angle is not 3. Um, Review in your visual acuity lecture about how when we're seeing a letter, we need the acuity to be able to discern like 1/5 of that letter to be able to correctly, consistently identify it on a visual acuity chart. So to figure out this angle, we take the MAR and we multiply by 3. So 3 times 15, 3 times 5 equals 15. And so this angle is 15, but not degrees, it's 15 minutes of arc. And so I'm just going to remind you that 1 minute of arc equals 1/60th of a degree. Okay, and then what we're solving for is how far we are. Um, so it doesn't come into play in this question, but just keep in mind the units that Dr. Nyman is asking for, because she will give you one part of it in feet or inches or centimeters, and then the answer will ask for a different unit. So you just know how to convert between feet to inches to centimeters and like back and forth between those. So we know, so we're always going to use like tan theta equals opposite over adjacent. And so our theta is 15 minutes of arc, which is the same thing as 15/60ths of a degree equals opposite over adjacent. So our opposite is this, and our adjacent is this. So our opposite is 5, and our adjacent is, we don't know. So if we do 10, 15 divided by 60, it equals 0.004363, whatever. So if you're getting a weird answer for this question, which I did too, it's because at this point, whenever Dr. Nyman wrote these problems, she rounded and just kept it as 0.004. So if we just use this number, equals 5 over x, we do 0.004x equals 5, and we solve for x equals 0.004 divided by 5, and we get, sorry, the other way around, 5 divided by 0.004, and we get our answer of 1250 feet. Remember, because this number was in feet, so our final answer will be in feet. Okay, and then now we have number 7, which is what I was talking about, where the question is given in feet, but the answer we're looking for is in inches. So again, we're going to be given two variables and we want to answer the third. So how large does a 2100 target have to be in inches when the room is 13 feet long with a chair 5 feet from the mirror? Okay, so this is the part you need to understand. So I can see why you would be quick to call, like if we draw a triangle again, I can see why you'd be quick to call our distance 13 feet. But remember, we're 5 feet from a mirror in a 13-foot long room. So let's say here's the chair, here's the mirror, and then here's the acuity chart. From here to here is 5 feet, and from here to here is 13 feet. So the total distance is 18 feet. So we know that this is 18 feet. And then we can figure out this angle from the acuity. So the acuity is 2100. We do 100 divided by 20. We get 5. We have to multiply this 5 to figure out the theta. So 5 times 5 equals 25. So now we have our equation. Tan theta equals opposite over adjacent. Tan theta is 25 over 60 equals opposite, which we don't know, over adjacent, which is 18. Okay, so yeah, tan 25 over 60 equals opposite over 18. So if we do tan 25 divided by 60, we get 0.00727 equals opposite over 18. And so if we just multiply that way, we multiply 0.00727 by 18, we get opposite equals 0.13 feet. But she wanted the answer in inches, so to go from feet to inches, we do 0.13 times 12, and we end up with 1.57 inches.